Today we are going to see about the configurations of transistors. So in the previous class we have seen about the construction and operation process of transistors. We have seen about two types of transistors, NPN transistor and PNP transistors. Today we will be seeing about the connections, how these transistors are going to be connected in an electronic circuit. So the bipolar junction transistors will be having three terminals. You know what are all the terminals. One is the emitter, second is base, and the third one is collector. So these three terminals are present in a junction transistors. Okay, these three terminals are present in the two types of transistors, that are NPN as well as PNP transistors. If you take an NPN transistor, you will be having base, emitter and collector. If you are taking a PNP transistor, it will also have base, emitter and collector. So the type of connection present or can be made in a transistors are of three types. Okay, so today we are going to discuss about the three types of configurations which are being used and what are all the available possibilities, and we are going in detail in common emitter configuration only because it is present. It is being used in a lot of places or lot of applications. So the first type is common base configuration. So regarding the common base configuration, this is the configuration for NPN transistor and this is the circuit connection for PNP transistors. Okay, here you represent this is the transistor and this is the emitter terminal, this is the collector terminal and this is the base terminal. Once you see the word common base, then the common base represent the base terminal is grounded. So what happens here, the base terminal, this point is grounded. So you see this is the negative terminal of the battery, and in VCC also this is the negative terminal of the battery. So you are applying the negative voltage, that is the 0 volt ground voltage to the base terminal, whether the emitter and the collector terminals are connected to the positive ends of the battery. So this is the NPN transistor configuration, and for PNP configuration also the same, but the transistor is PNP transistor. The next configuration you are going to see is common emitter configuration. Here you can see the emitter terminal, that is the emitter terminal of the transistor is being grounded. So the ground represents the polarities of the batteries. You see the VBB voltage, that is the base voltage, is being connected to the negative terminal of the VBB. So which represent this terminal is being grounded. The other two terminals, that is the collector and the base terminals, are connected with the external supplies VCC and VBB positive terminal. So once this arrowhead is connected in this position to these two batteries, then it is represented as common emitter configuration. So this is the same for the PNP transistor also. You can see the arrow mark of the transistor is being from the outer direction, which represents this is a common emitter configuration of a NPN transistor, and in this circuit you can see this is the common emitter configuration of a PNP transistor, because the arrow mark is showing that the current is inside the transistor flowing into the base. So the next configuration you are going to see is the common collector configuration. So in common collector configuration you can see the collector terminal is connected with the two batteries. You can see the VBB and the VCC voltages. This is the base voltage and this is the collector voltage. So recording the collector terminal is grounded. So due to this it is represented as common collector configuration. The other things remains the same. The base is connected to the VBB positive terminal and emitter is being connected to the VCC negative terminal. So this is the configuration for NPN transistor, and this below figure is for PNP transistors. So regarding this, you can see there are three types of configurations available. One is the common base configuration, common emitter configuration, and common collector configuration. So these three configurations are being used to connect the transistors into an electronic circuit depending upon its purposes. These three configuration has three different way of operation, and these three different way of operation lead to three different applications of the transistors. So the most commonly used application or the most commonly used configuration for a bipolar junction transistor is common emitter configuration. So let us discuss about these topics. The three configurations can be made with both the transistors, okay, NPN and PNP transistors. In the above three configuration, common emitter configuration is used because of its high voltage and high power gain. Okay, this common emitter configuration can handle a very high voltage as well as it has a very high power gain. Common emitter transistor configurations. Regarding this, you can see the circuit diagram for the common emitter configuration is shown. So here you can see this is the PNP transistor. Okay, this is the PNP transistor. You know this is the emitter, common emitter. So what you are going to do here is the emitter terminal of the transistor is going to be connected to the two ends of the battery. So you are going to connect this terminal to the two ends of the battery. Here the next thing is you are going to the base. The base of the transistor is connected to the negative terminal of the battery, and here you can see the collector terminal is connected to the load. This is the load. Okay, this is the load. Now in going deep, you can see this circuit, this circuit. Okay, if you see this, the base emitter, okay, the base emitter of the transistor is being forward biased. How it is being forward biased? You may check these things. Okay, the VBB voltage is negative here, and here it is positive. Okay, when going through this, the electron starts to flow through this. Okay, now you see this is the N terminal. So the N terminal is connected with the negative terminal, and here you can see this is the P terminal, and here the P terminal is being connected to the positive end. So what happens here is the base emitter junction, will be in forward biased. Okay, will be in forward biased. Next, when you are seeing the collector emitter junction, so this is the collector junction and this is the emitter junction. You can see the emitter junction, here is the positive P type semiconductor, and it is being connected with the positive terminal of the battery. And similarly here you can see this collector is a P type terminal, but it is being connected with the negative terminal of the battery. So what happens here is the collector emitter configuration is in reverse biased mode. So the next process you need to know here is the VBB voltage. The VBB voltage is the voltage which can be varied from 0 to 10 volt. Okay, similarly the VCC voltage is a fixed voltage. So this is fixed, it cannot be varied. Okay, now let us move here. you are having some measuring instruments such as ammeter connected in series, voltmeter connected in parallel, and here also you are having a voltmeter connected in parallel and ammeter connected in series. Next, this is the load resistance RL. So the demonstration, so regarding the demonstration, you need to see the PNP transistor is being connected in common emitter configuration as it is connected. The input voltage is applied across the base and emitter of the transistor. So this is the input voltage. So base and emitter, this is the base and emitter of the transistor. So this voltage VBB is represented as the input voltage of the common emitter configuration, and similarly the output voltage is taken from the collector and emitter terminal. So this is the output which is taken out, or it is being measured across the load. Okay, so the collector and emitter is going to give you a output of voltage regarding with the respect to the input voltage VBB. Regarding the characteristics of the common emitter configuration, you need to know this is the one type of lab experiment you are performing in the laboratory, so that you can plot the readings in a tabular column and then you are going to draw a graph. So the procedure to take the input characteristics of a common emitter configuration is you just connect these equipments as it is in a breadboard or in a simulation tool. Next, what you are going to do here is the input characteristics is drawn between VBE and IB. So here VBE represents the voltage across the base and emitter. So this is the voltmeter which shows you the voltage across the base and emitter. And there is another one thing which is IB. So IB is the current which is flowing through the base of the transistor. So IB current is present in y-axis and VBE voltage is present in x-axis. Now next you are going to draw the input characteristics of collector emitter voltage VCE, which is kept constant. So what the next step is, you are going to adjust or set the voltage VCE as a constant. How you make the voltage constant? You are already having a VCC battery which is constant, and this constant voltage is fed into a load resistance RL. So while adjusting the resistance of the load, you can set the voltage of the VCE to be a constant. Next, by changing VBE through VBB, current IB is recorded. So in the next step, what you are going to do is you are going to change this voltage VBB. So this is a variable voltage source, so you can change the voltage from step by step. So first you are going to change to 0.1 volt, next you are going to change to 0.2 volt, and then to 0.3 volt and 0.4 volt and so on. Okay, you are going to change the voltage VBB here, present here, and you are going to record the two values, that is the IB current. So you see the IB current and the VBE. You just change the voltage to 0.1 volt, use the voltmeter to see the value which is 0.1 volt, and then you note the current IB so that you can plot the graph. You change one by one, 0.1, 0.2, 0.3, 0.4, 0.5 and 0.8. Measure all the values in the voltmeter and the current ammeter and then plot this graph. Okay. So once this graph is plotted, it shows you the input characteristics of a transistor. The value of IB is very small. It is of the order of microamperes. So the current rating of IB, that is the base current rating of the transistor, will be very small, which will be in the range of microamperes. Next, When we are moving to the output characteristics, you may see the output characteristics is drawn between IC and VCE. So IC represents the collector current and VCE represents the voltage across the collector and the emitter terminal of the transistors. So the current which is flowing from the transistor collector towards the load, that gives the power to the load and return back to the emitter terminal, is represented as the output characteristics. So during the output characteristics, you are going to measure the range of current and the voltage along the collector as well as the collector emitter voltage. So regarding the experiment, we are going to draw our output characteristics. The base current IB is going to be kept constant at different values. So you see the graph. At the initial position, the base current IB is 0. So this represents you are going to decrease the value of the voltage VBB and make it as 0 in such a way that the base current, that is the IB current, read in this ammeter should be 0. After that, what you are going to do is change VCE through VCC and current IC is recorded. So next you are going to change the voltage VCE. To change this voltage, you need to adjust the voltage of VCC. So to apply a voltage or to change the voltage across the VCC, you need to change the resistance. While changing this resistance, the VCE is being changed, and depending on the resistance value, the current IC will flow through the resistance and return to the emitter. So what happens here is the IB is set constant, then you are going to change the VCE value from 2 volt, 4 volt, 6 volt, 8 volt, 9 volt and 12 volt. So you are going to change the voltage of VCE over here, and you are going to measure the current in y-axis of IC. So once it is in 0 volt, that is the VBE is in 0 volt and the base current is 0, you can see the voltage across the VCE goes on increasing, but the current, the IC current which is present in the collector is not there. Okay, so you can see it is a very less amount of current. It is a less than 0.5 milliamps is flowing through this ammeter or as a IC current. In the next stage, you are going to increase the IB value to 20 microamps. To do this, you are going to adjust this battery value to some other value and set 20 microamps in this ammeter. So you should adjust the voltage and set 20 microamps by seeing this ammeter. This represents 20 microamps of current is being passed into the base terminal of the PNP transistor. Once it is done, you need to repeat the steps. You are going to change the voltage VCE through VCC and record the current IC. So similarly, you again move from 2, 4, 6, 8, 10, 12, 14, 16 across the VCE voltage and record the current values. Then you can plot a graph like this. So repeat the same procedure for all these base currents and you can record these values and you can draw the output characteristics of common emitter configuration. This plot shows the output characteristics of the transistors. Next, on the observation from the characteristics of common emitter configuration, you may know it is seen that the small change in base current IB in microamps has a large change in collector emitter current ICE in milliamps. So what happens here is you are just changing the value of current in IB in a small step of microamps, but the collector emitter current is increasing or by a range of milliamps. So this is a major phenomenon that this transistor is being connected in common emitter configuration for most of the electronic applications. The current gain from the base to the collector is stated as beta DC. So this is the gain. So beta DC is represented as change in collector current divided by change in base current. So the beta DC is the gain of the transistor which is connected in common emitter configuration. Next, so the transistors can be used as an current amplification devices in common emitter configurations. The voltage gain, this is the current gain, whereas the voltage gain AV of the transistor is defined as the ratio of output voltage to input voltage. So the gain of the voltage gain AV is defined as output voltage divided by the input voltage. Here the output voltage is the voltage across the collector emitter terminal and the input voltage is along the base terminal of the transistor. So the major applications of common emitter configurations are: it is being used as a signal amplifier in most of the electronic circuits. The next, it is being used as an electronic switch. So the signal amplifier represents it is being used in amplification devices such as sound amplifiers, in microphone amplifier, or it is being connected to a speaker system as an audio amplifier. So in all types of amplification process, transistor is connected in common emitter configuration. The next is the electronic switch. So in electronic switch configuration, once you apply a small signal to the base of the transistor, it will connect a very large load into the supply. So what happens here is, if you are having a low input device such as microprocessor or microcontroller, and you are need to connect this microprocessor or microcontroller to a 230 volt supply or a relay, then you need to interface both these things with the help of an electronic switch. So in that case, the transistor plays a major role in connecting AC appliances or any other heavy loads into the required supply with the help of an electronic switch. So these are the configurations of the transistors and their application. In most of the cases, the common emitter configuration is used in a transistor. The other two configurations are useful, but they are extensively used for other purposes. Thank you.